Welcome back to the engine history, everyone. Right now, you are about to witness the cold start firing procedure of massive cast iron and steel power blocks after decades of being frozen in storage. This is not simply starting an engine. It is a stress test of mechanical materials under real combustion pressure. We begin with a V12 diesel tank power block with total displacement up to 39 liters, built to carry maximum load for the Tiger II chassis. Next comes the Argus pulse jet thrust tube mechanism, creating the eardrum tearing sound of an early cruise weapon. These military engine blocks were designed with zero concern for smoothness. The only goal was to grind forward, squeeze every ounce of output, and stay stubborn under battlefield punishment. After more than 30 years locked inside a container, has an 18-cylinder radial engine seized its piston rings or rusted its rocker gear solid? Or does it still have enough compression to roar back to life? You'll get the answer in the operating tests coming up. Speaking of pure, violent pulling force, we have to examine the configuration of a German V12 diesel stamped MAN V12 1800. With 24.2 liters of displacement, it forces out a peak output of 1,775 horsepower. Completely unlike classic naturally aspirated engines, this block is packed with a twin-turbo system, combined with high-pressure common rail fuel injection to maximize low RPM torque for maritime patrol propeller systems. This is the mechanical benchmark for the durability to pulling power ratio that marine operators are always chasing. Before we dive deep into the specifications of the 2,400 horsepower Griffon V12 block and the massive artillery tractor undercarriage, if you're the kind of person who lives for technical specs, loves the burnt bite of engine oil, and wants to hear real steel impact vibrations, hit subscribe to the Engine History right now. Don't forget to turn on notifications so you can stay locked onto rare documentary footage of teardown procedures and restorations of some of the rarest engine blocks in the world. Your support is the lubrication budget that keeps the team searching, buying back, and putting these heavy mechanical monsters onto a dyno table. Next, we return to the brutally practical construction of hard-working farm tractors across the United States. The Farmall Super MD has a very special start and run design. The mechanic primes the combustion process on gasoline using spark plugs and a gasoline ignition system. And once the block reaches optimal operating temperature, a lever system switches it over to run fully on diesel. Before electronic preheaters existed, this hybrid mechanical solution ensured the engine would always fire hard, even in sub-zero conditions. In the same era, the Rumely 3060E, carrying a 13-ton body, was a true iron workhorse. With only two massive cylinders and a cooling system holding up to 85 gallons of circulating water, it delivered stubborn, winch-like pulling power for deep plowing, setting the standard for toughness before high-speed diesel technology took over the market. One of the engine blocks that pushed piston-era power output to its limit is the Griffon V12 Mark 58. With 36.7 liters of displacement and more than 2,400 horsepower, it is considered the upper boundary of piston, aircraft-style internal combustion power. Its torque is so extreme that if it drove a single propeller, the twisting force would flip the aircraft. That is why it had to carry a complex power-splitting gearbox to drive contra-rotating coaxial propellers, canceling the torque reaction, serving late-model Spitfires and the Shackleton patrol aircraft. This gear train structure is a dense, mechanical nightmare that demanded the tightest machining tolerances, and today it has essentially vanished. In armored vehicles, the cold start firing of a 38-liter aluminum cast V12 diesel inside a 1944 T-3485 tank is an extremely harsh technical test. After decades of dust and storage, restoring lubrication to the cam train, bleeding air from injector lines, and bringing RPM up safely requires the mechanic to set injection timing precisely and measure compression carefully. Similarly, a Curtiss-Wright R3350 18-cylinder radial engine, after being left for 32 years, proved the perfection of its bearing tolerances by starting successfully and producing a sharp, hard-edged roar without any valve knock. Moving into the high-speed weight class, we analyze exhaust flow from a jet engine. The Fire Force 5 drag car chassis was launched by maximum thrust to over 482 kilometers per hour in only 5.3 seconds. The piercing shriek, the pressure shock waves, and the afterburner flame blasting from the jet nozzle create a physical force that pins the driver into the seat. Within the same system, Martin Hill's Fire Force 3 record also tore past 265 miles per hour in 6.7 seconds. This is the territory where steel tube frames and aerospace materials are tested at the absolute edge of structural tolerance. Even at the smaller scale, like the horizontally opposed four-cylinder boxer of the Volkswagen Type 1 in a bug chassis, when mechanics install a performance camshaft, overbore the cylinders, and open up the intake throat, the engine produces a brutal result on the dyno. 105 horsepower and 152 Newton-meters of torque. That data proves a classic mechanical engine platform, when tuned correctly for ignition timing and air-fuel ratio, can be pushed far beyond what people assume. To understand why blocks like the Griffon V12 Mark 58 or the 39-liter Panzer V12 can stay brutally stubborn under load, real mechanics have to break down power-to-weight ratios and heat treatment metallurgy. When modern engines survive by leaning on electronic circuit boards, wartime machines survived by relying on the hardness of camshafts, rocker gear, and the mechanical lever systems inside high-pressure injection pumps. The Allison V1710, producing around 1,000 horsepower, is a classic configuration using closed-loop liquid cooling combined with a supercharger to drive combustion pressure to the maximum threshold without cracking the block. The long-life survivability of the Curtiss-Wright R3350 radial depends entirely on its oil pump system, with 18 cylinders arranged as 2 radial rows, delivering pressurized lubrication evenly to all the articulated link rods attached to a single master rod wrapped around the crankshaft is an extremely difficult hydrodynamics problem. After sitting dead still for 32 years, the lubrication clearances of the cam train and valve gear still held tolerances within thousandths of a millimeter, allowing the oil pump to build full pressure and restart the engine without pulling it for an overhaul. That is hard steel evidence that 1940s heat treatment metallurgy had already reached a level designed to grind until worn out, but not to crack and fail. The hard-edged exhaust bark from the Rumley tractor stack or the Sherman M4A1 tank is not display sound. It is a living measurement of a correct compression and combustion cycle inside a fully mechanical system. Thank you for taking the time to follow this technical teardown analysis on the engine history. In today's heavy engine lineup, are you more impressed by the connecting rod system of the R3350 radial or the raw thrust of the jet engine? Leave a technical comment below so everyone can compare specs together. Goodbye, and see you again in the next engine teardown session.